A celestial body has just burst into action close to the sun, its luminosity surging dramatically in a single night, with the tail expanding to span over 5 times the width of a full moon. Shortly after, the sun fired off its most powerful solar flare in months, hurling a huge plasma surge directly at the region of space where Comet R2 Swan, as noted in the title, is racing toward our planet. Come October 21st, Swan will approach its nearest point to Earth right as another object from beyond our solar system aligns in an almost perfect formation. As incoming solar disturbances collide with the comet's enormous tail, the outcome remains a mystery. Could the heavens ignite with spectacle, or will it all fade quietly? The sequence of events is underway. So, what unfolds when solar fury encounters this interstellar guest? On September 12, 2025, Comet C/2025, now known simply as Swan, orbits the Sun at a mere half an astronomical unit away, nearer than Mars ever gets to our world. Initially, the data appears ordinary, a dim, gradual brightener with a magnitude around 7.4 and a tail extending just 2 degrees across the evening sky. Yet comets thrive on the unexpected. Only 2 weeks after reaching perihelion, the illumination spikes sharply. On September 26th, hobbyists in Japan and Australia detect the initial indicators. An abrupt increase of almost 1 full magnitude catapults Swan into visibility for the unaided eye under clear, dark conditions. By day's end, online communities worldwide are alive with real-time measurements, verifying a jump to magnitude 5.7, stabilizing around 5.8 by September 28th. This surge goes beyond mere fluctuation. Such explosions trace back to the core, a icy nucleus scarred by eons in the void, now pummeled by intense solar radiation. As Swan arcs away from its sun-closest point, hidden volatile reserves under the surface hit their limit. They erupt, spewing gases that drag along ice and debris, expanding the coma and bolstering the tail. The impact hits fast. Brightness patterns stray from forecasts, and each new sighting offers insights into subsurface dynamics. Heat-induced strain, gas releases, or even partial breakdowns are all possibilities. Certain watchers notice suggestions of jet streams emanating from the nucleus, potentially signaling cracks in the crust or emerging outlets. Swan's actions stray from typical patterns, captivating experts and a worldwide cadre of amateur stargazers alike. At present, the evidence is unmistakable. Swan has shifted into an active stage. Its core mechanisms laid bare, future developments hard to foresee. Beyond peak brightness, the real intrigue lies in how this released power affects the comet's framework and the sprawling tail trailing in its wake. That tail now measures over 2.5 degrees wide, equivalent to 5 full moons aligned tip to tip. For those scanning the skies, this vastness transforms the view. No longer a mere smudge amid the stars, it's a formation trackable through binoculars, a prominent streak noticeable even from light-polluted areas. Such breadth exposes more of the comet's inner workings. Clumps of particles, evolving beams, and the subtle azure glow of the ion tail, all molded by the sun's outflow. The tail's design narrates an ongoing tale. The dust component, denser and more sluggish, hugs the comet's trajectory, creating a wide, illuminated arc. In contrast, the ion tail, finer and more reactive, might twist, undulate, or detach entirely amid favorable solar influences. With Swan's appendage now dominating a swath of sky broader than any urban horizon, modest scopes reveal details, flows, curves, and abrupt turns. For those monitoring sequentially, the evolutions stand out clearly. One night might unveil a fresh curve, a dimming stream, or a quick flare as new ejecta flows from the heart. The international comet enthusiasts are mobilizing. Enthusiasts spanning the globe are layering images, exchanging insights, and posting animations that capture tail shifts by the hour. Discussion boards overflow with accounts of nuanced hues, cool blues from charged particles, warm golds from grains, alluding to intricate compositions. Swan's low placement in the southern hemisphere during late September and October benefits viewers in Australia, South Africa, and Argentina. Yet northern regions gain opportunities too. as the comet rises and the moon dims. For holders of basic binoculars, the coming weeks provide prime access to an unfolding display of cosmic mechanics. The tail's extension goes further than visual appeal. It primes the arena for solar impacts in that same spatial sector. The puzzle shifts from mere elongation to responsiveness when the sun's gusts strike. On September 28th at 0843 UTC, the sun unleashes an M6. For flare, its fiercest in recent months. Throughout most of September, sunspot activity stayed subdued, with X-ray levels from GOES satellites remaining steady, suggesting a pause in the ongoing solar cycle. Abruptly, the detectors surge. The flare's power, quantified in millions of kilowatts, illuminates GOES 16 and GOES 18 displays almost instantly. Solar experts at the National Oceanic and Atmospheric Administration Space Weather Prediction Center quickly mobilized to evaluate the incident, verifying details against observations from the Solar Dynamics Observatory. Images and coronagraph readings from the Solar and Heliospheric Observatory added further clarity. This incident goes beyond a typical solar disturbance. M-class flares rank in the middle of the intensity spectrum, yet an M6. For event demands scrutiny from satellite managers and space weather experts alike. Emerging from active region 4232, an intricate cluster of sunspots featuring a convoluted magnetic structure, this flare positioned itself in the solar quadrant that Comet Swan is currently nearing. Barely 30 minutes later, coronagraph instruments verified the release of a coronal mass ejection. Clocking an early velocity of 800 to 1,000 kilometers per second, the CME stands out as one of the swiftest outbursts this year. In control centers, warnings spread rapidly. Spacecraft operators reviewed safeguards against radiation surges, though this particular CME posed no threat to our planet. Attention turned instead to potential impacts along its trajectory. Occurring merely 2 days following Swan's own activity spike, the episode sparked instant interest. On-duty personnel highlighted it for comet specialists, prompting simulations of any potential clash between the CME and Swan's elongating ion tail. At present, the data paints a vivid picture, an M6. For flare erupting at 0843 UTC, a CME hurtling into space, and a comet boasting a tail exceeding 2 degrees in width directly in the line of potential influence. After weeks of solar calm, the star unleashed a robust surge toward the very region where Swan continues its spectacular performance. Such overlaps are uncommon, compelling every tool, from GOES X-ray sensors to Earth-bound observatories, to monitor intently. Within the NOAA Space Weather Prediction Center, efforts kicked off the moment the flare reached its climax. Experts accessed live streams from SOHO's LASCO coronagraph and Stereo AS heliospheric views, scrutinizing sequences for signs of the broadening plasma front. The CME, ejected shortly past 0845 UTC, expanded with a starting pace around 900 kilometers per second, rapid enough to span the typical Earth-Sun gap in under 2 days. Spanning about 90 degrees in angular breadth, it qualified as one of the year's more expansive expulsions. Yet its direction proved pivotal. This outburst veered far from Earth. Projections indicated its primary plume arcing toward the spatial zone currently hosting Comet Swan. For prediction specialists, the puzzle hinged on spatial alignment. Solar blasts rarely follow tidy paths. They balloon, curve, and occasionally splinter amid the solar wind. To map the route, researchers merge coronagraph visuals, tracing the forefront relative to established spots of planets, probes, and, remarkably after years, a comet sporting a tail over 2 degrees long. Positioned just beyond Earth's orbit and a bit below the ecliptic plane, Swan's location aligned closely with the forecasted pathway, though three-dimensional ambiguities lingered. Absent a direct planetary strike, in situ plasma measurements stayed out of reach, relying on terrestrial and space-based optics to observe the interaction. Leading prediction hubs alerted comet investigators to the development. The key uncertainty: would the CME's expansive leading edge truly engage Swan's tail, or merely glide by without contact? Projections estimated the CME reaching the comet's area 48 to 72 hours post-launch, varying by actual course and velocity. Density forecasts pointed to a middling disturbance, sufficient to unsettle the ion tail, yet improbable to cause ground-level disruptions. Earth's exposure remained low. For Swan, however, the approaching solar plasma primed conditions for striking tail distortions, separations, or abrupt shifts. Such spectacles might develop over mere hours, observable by skywatchers tuned to the appropriate celestial sector. Equipment stood primed. Data flows activated. Focus now pivoted to the comet's pathway. Magnetic forces dictate the destiny of any comet tail ensnared by the solar wind. As a coronal mass ejection, like the one dispatched on September 28, surges through the void, it hauls along a knotted network of magnetic lines, each with distinct alignment. A comet's ion tail forms from ionized gases liberated from its core and repelled by the sun's ceaseless emission. These particles don't simply wander. They adhere to magnetic strands, creating an unseen anchor extending millions of kilometers behind the nucleus. The true spectacle ignites at the interface where these strands encounter the oncoming solar wind. Should the embedded field in the coronal mass ejection align southward, counter to the norm around the comet, setup favors magnetic reconnection, as termed by physicists. This mirrors a fuse blowing in the heavens. Lines from the solar wind and tail clash, rupture, and swiftly reconnect in fresh configurations, liberating bursts of energy and severing plasma segments outright. In essence, the tail might detach in moments. As observers spot a luminous piece of the comet's tail floating away into the void, a fresh appendage starts shaping up right away. The direction of the coronal mass ejection's magnetic field, particularly its BZ element, dictates how intense this interaction becomes. A southward BZ stands out as the prime catalyst for cleaving the tail, whereas northward orientations might glide past, causing only minor disturbances. This phenomenon unfolds swiftly, often detectable in mere hours, resulting in striking bends, abrupt fades in luminosity, or isolated blobs of ions drifting on their own. For researchers and simulators, it's an exceptional opportunity to witness magnetic reconnection unfolding on a grand scale beyond any lab setup. Each contortion and fracture etches itself across the heavens live, making every moment precious. The phase for significant shifts has arrived, governed by straightforward principles. Monitor the tail closely, rely on your observations, and stay adaptable in your forecasts. Swan's ion tail, stretching over 2.5 degrees in length, faces the unbridled push of the solar wind head-on. Should the CME's field lines cross the comet's trajectory, the ion tail might twist or detach in under 90 minutes, a sequence that typically happens discreetly far from view for other comets, yet here unfolds before amateur scopes. Emission lines could jolt suddenly, with hydrogen and oxygen features shifting by as much as 50 kilometers per second amid the plasma's response to the impact. The tail's shape might evolve quicker than a film sequence, featuring a vivid strand snapping loose or a replacement tail emerging post-separation. This represents astronomy in motion, where top insights could emerge from everyday enthusiasts armed with a lens and unobscured views. Yet restraint is key. Not all wavers or quick darkenings signal a solar outburst. The CME's trajectory alignment remains uncertain, and ideas of head-on collisions are still speculative rather than confirmed. Specialists call for alertness over assurance. The ideal action involves recording, cross-referencing, and sharing, amassing a worldwide archive as the comet's narrative progresses. At present, the sole certainty is transformation. The following oddity might emerge in one snapshot, with global eyes united in anticipation. October the 21st, 2025. The figures paint the picture. Swan will glide within 0.25 astronomical units of Earth, roughly 39 million kilometers, or around 100 times the lunar distance. For a comet, such proximity mimics a near-planetary skim. This isn't mere happenstance. The setup aligns near ideally. Swan's path schemes the ecliptic at a gentle incline, traversing the unseen layer that serves as the solar system's primary thoroughfare. Positioned slightly below the ecliptic, the comet sits right in the heart of where solar wind and the heliospheric current sheet exert the strongest influence. That very day, the interstellar guest 3, I/Atlas, hits superior conjunction, positioned straight across from the Sun as viewed from Earth, as Swan hits its perihelion sweep. Though separated by vast distances, these two entities in parallel paths provide a unique side-by-side look at local versus extrasolar behaviors. To trajectory experts, this setup defies probability. The chances of a deep solar system wanderer and an interstellar intruder aligning near the ecliptic within days are extraordinarily low. The schedule adds to the intrigue. October 21st coincides with a new moon, wiping out moonlight interference for the month's blackest nights. At peak closeness for Swan, even basic home telescopes can detect the parallax, subtle positional jitters from various earthly vantage points. Position tracking reveals Swan ascending nightly, its tail carving through southern star patterns. The real-time Earth-comet divide narrows to a quarter of the Earth-Sun span, delivering prime viewing conditions before Swan fades back into the cosmos. For those eager to spot Swan over the next evenings, precision and readiness matter most. October 21st marks the peak moment. Minimum distance, new moon, and optimal darkness. Yet the opportunity extends. Swan's route dips south of the ecliptic, rising progressively through southern skies. From Buenos Aires to Perth, it appears soon after dusk and holds through to dawn, its tail arcing westward over the skyline. Up north, visibility sharpens as the month advances, with Swan cresting the horizon post-midnight and elevating further nightly. Constellation maps locate Swan along the edge of Gross and Piscis Austrinus. Spot it easily by drawing from Fomalhaut Fo Mala, the area's luminous star. The tail's alignment suits direct contrasts with nearby stars. At 2.5 degrees, the comet's streak spans the interval between Halt and its closest companions. Binoculars with a 7x50 view encompass the full tail effortlessly. Compact scopes uncover finer points. Though even a basic tripod allows you to snap that streaking trail using exposures as short as a couple of seconds. The parallax method kicks in as Swan draws nearer. Positioned merely 0.25 astronomical units from us, the comet's spot in the sky nudges subtly based on your viewing spot. It's in shift you can detect with several hours of steady watching and sharp attention. Hobbyists snapping photos are teaming up worldwide, recording when it rises and sets, and exchanging layered images to follow the tail's daily shifts. The routine is straightforward. Mark the comet's location, draw or snap the tail, and keep an eye out for bends, abrupt glow-ups, or dimming. No matter if you're amid urban lights or out in the countryside's blackness, each watcher contributes a vital detail to the worldwide view. Now's the time to get involved in the monitoring. This uncommon alignment paves the way for a well-recorded brush with destiny. With Swan hitting its nearest point to our planet on October 21st, roughly 0.25 astronomical units distant, researchers are eyeing potential straight-up impacts from the CME on the comet's ion tail. It's a process recognized for sparking quick, eye-catching alterations. Still, the precise results of this Sun-comet clash are yet to be tested, and there's no confirmed tie between the latest solar eruption and Swan's prior flare-up. What's certain this October is that both casual stargazers and pros get a special chance to see comet behavior and solar happenings unfold live. Through the international tracking effort, Swan's path offers a scarce shot to monitor these space powers in action, with major findings still emerging.